In this video, we will be doing the fourth part of the review for Chem 111 for their final exam, and it will be focusing on molar mass and molar conversions. So when we're looking at molar mass, don't get thrown off. Atomic mass, molecular mass, ionic mass, formula unit mass, all of those mean the same thing. It just means molar mass. It means you're going to look on the periodic table for the specific elements that are involved in the compound and figure out the masses of each of them and how much they contribute to it. So for instance, lead sulfate, lead is here, is 207.2. We only have one of them because there's an invisible one there. So it becomes 207.2 grams per mole for the lead. Sulfur, once again there's one of them here, is right here at 32.066. This will be the only one in which I don't round off to the 10th place, by the way. Oxygen is here, and there's four of them. Here's oxygen at 15.999. Times 4, because now we have four of them. That's going to equal 63.996. You add these numbers together, and it comes out to be 303.262, and the units we're going to use is grams per mole. The technical unit is atomic mass unit, AMU, but typically when we start using these in conversions, we automatically convert it over to grams per mole because it's easier to deal with calculations. So let's try to find another one. Ammonium carbonate. So we have nitrogen, hydrogen, carbon, and oxygen. This 2 gets distributed to both of these elements. So we actually have 2 nitrogens. 4 times 2 is 8 hydrogens, 1 carbon, and 3 oxygens. Now once again we go back to the periodic table. Nitrogen is 14.0. So that comes out to be 28.0. Hydrogen is 1.0. So that comes out to be 8.0. Carbon is here at 12.0. I lost my spot, hold on. 12.0. And then finally, oxygen is here at 16.0. 3 times 16 is 48.0. We're going to add those together, and that's going to come out to be 96.0 grams per mole. Once again, if you see AMUs, don't get thrown off. That's the actual formal unit. Alright, so let's use these numbers, these molar masses, in a conversion factor, as conversion factors, as I mentioned earlier. So convert 2.50 moles of Kl, potassium chlorate, KClO3, to grams. Grams is your dead giveaway. That's your key term for looking for the molar mass. So as soon as you see G for grams or the word mass, you automatically know that you're going to have to figure out the molar mass of that compound. So let's do that first. So we have K, Cl, and O. We have 1 potassium, 1 chlorine, and 3 oxygens. We look on the periodic table. K is here, 39.1. That comes out to be 39.1. Cl, wrong way, Cl is here, 35.5. That comes out to be 35.5. And oxygen is here at 16.0. So 3 times 16, once again, comes out to be 48.0. Add all those up, and that comes out to be 122.5 grams per mole. And that becomes your conversion factor, meaning you have 122.5 grams is equal to 1 mole. Just like miles per hour, that's how many miles you can drive in 1 hour. That's how many grams you can have in 1 mole. So we put our starting number over 1, 2.50 moles of KClO3 over 1. We have moles of KClO3 on the top. We're going to put moles of KClO3 on the bottom. Notice that the 1 goes with moles. 122.5 grams are in that many, is the molar mass. So it would be 2.5 times 122.5. That comes out to be 306 grams of KClO3. Let's try another one. How many moles are in 17.0 grams of H2O2? Notice the word grams. That means I'm going to need the molar mass of H2O2. So H and O, we have 2 of each. Hydrogen is here, is 1.0. Oxygen is right here, it's 16.0. 2 times 16 is 32. Add those together and it comes out to be 34.0 grams per mole. That becomes our conversion factor of 34.0 grams is equal to 1 mole. So from here, we can put the number we're trying to convert, which is 17.0 grams of H2O2 over 1. We have grams on the top, that means we're going to put grams on the bottom. 34.0 goes with grams. That's equal to 1 mole. So that's going to go on top. The grams cancel. That leaves us with moles of H2O2. And that comes out to be 0. In your calculator, it probably says 0.5. But because of the fact that there's 3 significant figures there, we want to make sure that there's 3 in the answer. So 0.500 moles of H2O2. Okay, so I mentioned that the molar mass, the word grams was the key term for molar mass, or the word mass is the key term for molar mass. The term atoms, there's ions, molecules, or formula units. One of those 4 will be the key term for Avogadro's number. Which is 6.02 times 10 to the 23rd. You're looking for the words atoms, ions, molecules, or formula units. One of those 4 terms automatically tells you you're going to use Avogadro's number. Okay, so from here, 0.750 moles of Fe over 1. Avogadro's number will be 6.02 times 10 to the 23rd moles is equal to, atoms is equal to 1 mole. I got ahead of myself, I apologize. So we have moles on top. We want to put moles on the bottom of the next one. 1 goes with moles. Then the 6.02 times 10 to the 23rd atoms goes on top. So 0.750 times 6.02, remember you use the EE or EXP for the times 10, so 6.02 EE23 and that comes out to be 4.52 times 10 to the 23rd atoms. Finally, our last example is we're going to combine those two numbers, those two sets of key terms. We have grams, which tells me I need to get the molar mass of iron. Iron's all by itself here, so we have 1 times, iron is here, 55.8. And we have the word atoms here, which tells me we're going to use Avogadro's number. Now we start with our first number, 0.45. We have grams on top, so we're going to put grams on the bottom of the next one. That's our 55.8 is equal to 1 mole. We have moles on the top, which means we're going to put moles on the bottom of the next one. That takes us to Avogadro's number of 6.02 times 10 to the 23rd. Okay, so the biggest issue I see students have on when these types of questions is when to use what and where to put the numbers. I've already mentioned grams and mass is the key term for molar mass, which means you're going to be looking at the periodic table. And atoms, ions, molecules, and formula units takes us to Avogadro's number. So whatever numbers on top, whatever units on top needs to be the unit on the bottom of the next one. The molar mass breaks down to 55.8 grams is equal to 1 mole. So 1 always goes with moles. The only time it doesn't is when you're incorporating a chemical formula, and we're going to talk about that in another tutorial. So 55.8, or the number you calculate from the periodic table, will always go with grams. So the grams cancel. That puts us with moles. I usually cross out what I've used so I don't get it confused, because if I look at the numbers again, I see moles in 2 different places, and I don't want to keep using the same number over and over and over again. So I cross it out so I don't use it again. So I have moles on the top, so I put moles on the bottom. Then the number we're looking for is going to be on the top of the last line, the top of the last fraction. So it's going to be 0.5450 divided by, because it's on the bottom, 55.8 times 6.02 EE23 because it's on the top. And that comes out to be 4.85 times 10 to the 21. Notice there's 3 significant digits. That 0 does not count, but that 0 does because of the decimal. So I want 3 significant figures in the answer. And I hope you are understanding this. If not, you need to go back and look at other tutorials.